Hi everyone, this video is on exercise 1E question 12 of A-level maths pure 2. So we have a function f of x and we also have the diagram, and the function is basically valid for the values of x between 0 and pi. So the curve has a maximum and minimum turning points at A and B, as you can see on the diagram. And the first part says that show that the x coordinate of points A and points B are solutions to this equation. Okay, so as usual, whenever you want to find the x coordinate of the stationary points, you should use the fact that you need to find the derivative, because when you find the derivative and then set that equal to 0, the solutions to that equation are going to be the x coordinates of the stationary point or points. So in this case, we have the function 2 cos 2x divided by e to the 2 minus x, and we want to find the coordinates of the stationary point. So we need to first find the derivative of this, which is the quotient rule. So the denominator function is going to be a squared because this is a quotient rule. So as usual, we square the denominator function, and then we write down the denominator function on the numerator and multiply that by the derivative of the numerator function. So the numerator function is 2 cos 2x. So remember that these types of differentiations, when we have a trigonometric function, we basically both differentiate the trigonometric function and also the function that is inside of that. So in this case, inside is 2x. So if we differentiate that, we get 2. So 2 comes out, and also cos itself differentiates to minus sign. So basically we have two operations going on at the same time. So as a result of that, we are going to have, remember, we have a 2 as a coefficient, and another 2, which is the derivative of inside of the bracket. So because 2x differentiates to 2, so that comes out. And then we write down, sorry, cos differentiates to minus sign. So negative sine 2x. And we can simplify this, but we'll do that later. Also, the second part for the differentiation is now writing down the numerator function times the derivative of the denominator function. So in that case, we are going to write, first of all, 2 cos 2x times the derivative of the denominator function is basically so my 2 minus x is the power, and that differentiates to just minus 1. So minus 1 comes down, and it's just going to be minus basically the function but negated, minus e to the power of 2 minus x. So that's the derivative of that. And at this point, we can simplify this, but before that, yeah, one simplification that we can here have is we have e to the minus 2x. This is a common term, as you can see. We have that here. So we have e to the minus 2x here, this bracket, e to the minus. This is negative, but it's fine because we can get rid of the negative because we have a negative here also. So that negative with this negative, makes positive. That's fine. I will change that in a bit. Also, we have another e to the power of 2 minus x in the denominator, but this one is a square. So let me simplify that so you will see where I'm going with this. So denominator is still e to the minus 2x squared. And then here for the numerator, I write down e to the 2 minus x times, for the second bracket, we have 2 times minus sine x, so just minus 4 sine 2x, minus, and then for the second bracket, oh yeah, we had a negative here and then a negative here, so it's just going to be positive, and we keep 2 cos 2x, and then e to the 2 minus x. Okay, at this point, we can divide each term by e to the 2 minus x because that's common in every single term. So that's just a trick that helps us to get rid of e to the minus 2x in the numerators. So basically, this e to the minus 2x cancels out with this e to the minus 2x with the power of here, because you remember the denominator is a square. So you are going to get e to the 2 minus x minus 4 sine 2x plus 2 cos 2x. Okay, this is a good point to stop and then set this basically 0, because we want to find the stationary point. So when this is equal to 0, what's going to happen is that we can do a cross multiplication, and that cross multiplication helps us to get rid of the denominator. So we are just going to have minus 4 sine 2x plus 2 cos 2x is equal to 0. Then let's rearrange this. So 4 sine 2x is equal to 2 cos 2x. Now we can divide both sides by 2. So this one will cancel out with here, and we're just going to have 2. So we have 2 sine 2x is equal to cos 2x. Let's divide both sides by cos x. So we are going to have, remember that sine 2x divided by cos 2x is tan 2x. And on the right hand side is just 1. So one final division, which is dividing both sides by 2. And tan 2x is equal to a half. Now this is useful. Also, we have answered part A because the objective of part A was showing that we can find the basically x coordinates by solving this equation. Tan 2x is equal to a half. Right. Part B says find the range of f of x. Okay, if you want to find the range of f of x, we need to have the coordinates, the y coordinates of the stationary points, because that's going to be useful for us. I mean, a stationary point B specifically, and you will see why once we do that. Because once we have the solutions, I can explain better why the stationary point of B is important for us to answer part B of the question. So in order to find that, the stationary points, we first need to find the x coordinates, and that can be done by solving this trigonometric equation. So if you want to solve this trigonometric equation, just remember that since here we have 2x, this is quite important, because also if you look at the top, the value of x is between 0 and pi. So x is between 0 and pi, but remember here we have 2x. So we multiply everything by 2. That's very important in questions like this. Always look at the value of the domain, which is basically the values of x, and also what you have in your trigonometric equation. If it's 2x, multiply everything by 2, and so on. So in this case, it's going to be 2 pi. This is quite important in terms of solving questions like this. Because now we need to find our solutions that are between 0 and 2 pi, and later on we divide everything by 2, just to have everything as between 0 and pi again. But that's the final step. Okay, if we want to solve this, we just basically do tan inverse, and remember that if you find a tan inverse of a half, then you are going to get the value on your calculator as 0.4436, and this is approximate because I have rounded that. And the thing is that the tangent, when you have a tangent, the solution repeats every pi. So in order to have the second solution, you add pi to this one, so to this solution, to find the next solution. So your next solution is basically 0.4436 plus pi, which is basically equal to 3.6052. Again, these are rounded. These values are rounded. Right, now you have 2x is equal to these values. So obviously you want to find the x. So you just divide all of these values by 2. Then you are going to get 0.2318, and for the other one is 1.8026. So this step is very important now, because you need to decide which of these values should be used. So let's go back to the curve. So this is the graph of that. Now, if you want to find a range, remember that you need to start from the lowest part of the graph and go to the highest possible part. So that allows you to find a range, because range is telling you the values of y, the y values basically for your graph. So that's why you start from the bottom and go to the highest. So now you might be saying, okay, the highest is here and it just keeps going to infinity. But that's a common mistake, because you need to note that x value is between 0 and pi. So that means you need to find f of pi, because f of pi is going to give you the highest value of the function. I mean the highest y value. And that highest y value is like the upper bound of your function. It's not plus infinity. Because again, x is limited. X is not, for example, between 0 and infinity, for example. So yeah, in that case, so you already know the coordinates of the x coordinates of b, because you just calculated that. That's here. This is the x coordinate of b. Remember, this one is for a, but it's not useful for this part of the question. This is the x coordinate of b. So x coordinate of b. And that's here. So that's 1.8 something. So that's the x coordinate of b. You want to now know the y coordinate of b, and also the y coordinate when your function is, your x is equal to pi. You want to see what's the y coordinate, because that gives you the highest possible y coordinate in this question. So that means what we are going to do now is that we can write that the range of the function is between f of 1.8026. Again, that just means the y coordinate of point B, and so y itself, because again we are just writing down the range, and f of pi, so the y coordinate of this point, which is the highest possible point in this case. So yeah, it just basically calculation at this point. Here it gives you 1.047, just substituting this into the original function, and here is 6.26. So yeah, this is how you can find the range for this question. So yeah, it had multiple steps. Yeah, thank you for watching. See you in the next video.